All right, so we're moving into properties of multiplication of rational numbers. This first property is the identity property. We've seen this with the integers and with whole numbers. We have the same identity in the rational numbers for multiplication. So if I multiply any rational number by 1 on either side, I get that rational number back. This bottom one is new, the multiplicative inverse or reciprocal. So given any rational number a over b that's non-zero, then b over a is the unique rational number such that when I multiply a over b times b over a, I get the identity 1. And vice versa. If I multiply b over a times a over b, I also get 1. So in the rational numbers, we get multiplicative inverses. This wasn't true in, say, the integers or the whole numbers. For example, 2, there's no whole number that I can multiply by 2 and get 1 back. I have to move into the rational numbers to multiply 2 by 1/2 to get 1. All right, these other properties are the properties that we've seen before. So the distributive property, we can distribute multiplication over addition just like we did in the other number systems. We want this multiplication property of equality that says if I represent my fraction a over b as c over d, then when I multiply it by another fraction, I get the same result as if I had multiplied c over d times that other fraction. So it doesn't matter what representation of a fraction we use. Properties of equality. So if I have a rational number a over b is bigger than c over d, and e over f is a positive rational number, then I can multiply both sides of the inequality here by e over f, and the inequality doesn't change, right? If e over f had been negative, then when I multiply both sides by the inequality, or both sides of the inequality by e over f, notice that the inequality flips. Okay? And of course, if I multiply any rational number by 0, I get 0. Okay, so our new property really is the multiplicative inverse. So let's just make sure that we're confident with this. So when we're looking for the multiplicative inverse, we're asking what's the rational number that I multiply my number by to get 1. So if I want the multiplicative inverse of 3/5, it's going to be 5/3. And that's because 3/5 times 5/3 is 15 over 15, which is 1. All right, I would recommend that you pause the video for a second and fill out these multiplicative inverses for B, C, and D, and then come back and make sure your answers match mine. So I'll give you a second to pause, and then I'll keep going. All right, so what about for B? What's the multiplicative of negative 2/3? Well, I need to multiply negative 2/3 by negative 3/2 to get 1. So I just take the reciprocal, and if I've got a negative out front, I need that negative on the reciprocal. What about 0? Does 0 have a multiplicative inverse? What can I multiply 0 by to get 1? Well, we just saw on the last slide that if I multiply any rational number by 0, I get 0. So 0 doesn't have an inverse, multiplicative inverse. And finally, what about D? I have 4 2/3. Now, I know some of you are going to look at this and want to just take the reciprocal of 4 and the reciprocal of 2/3, but that's not going to work. So what we need to do here is first convert this to an improper fraction. So 4 2/3 is the same as 12 plus 2, which is 14 over 3. And now I can take the reciprocal to get the multiplicative inverses 3 over 14. Okay, so be careful with your mixed numbers. You've got to convert them to an improper fraction before you try to find the multiplicative inverse. All right, so now students can do word problems with fractions. So let's look at a sample problem. A bicycle is on sale at 3/4 of its original price. If the sale price is $330, what was the original price? Okay, so I want to look at this two ways. One using algebra and one using a picture. So let's start with the algebra. Well, we want to know the original price, right? And we know that 3/4 of the original price is what the bicycle is on sale for. Okay, so that means that 3/4 of the original price, so that's times here, equals 330. And so if we let X be our original price, (3/4) X equals 330. And to solve, we're going to multiply both sides by the reciprocal, or the multiplicative inverse, of 3/4. So on the left, everything cancels. I'm just left with X. On the right, I have 330 over 1 times 4/3. And I can cancel a little bit here just to make my multiplication easier, right? So I can cancel 3 into 330. I'm left with 110 on top and 1 on the bottom. And so that's going to give me a final answer of 4 times 110, or 440, and those were dollars. Okay, so that's the algebraic approach. You can also take a pictorial approach. So I'm going to think of this bar as representing the original price. And so this is my whole, or 1, and over here is 0, and I want to break it into fourths. So 1, 2, 3 here. And I know that 3/4 is here, and 3/4 of the price is $330. So if I want to know what the original price was, well, I know that these pieces here must all be equal sized, right? And there are 3 of them, and they have to add up to 330. So that means that these pieces must all be $110. And that forces the last piece to also be the same size, 110. And so the original price is found by just adding up all the pieces. In this case, I have 4 pieces that are all worth 110, or $440. All right. Okay, I want to talk about one last thing in this video, and that's multiplication with mixed numbers. So we're going to talk about 2 approaches for doing that multiplication. The first is just to convert to improper fractions. So here I have 2.5 times 2.5. I just convert each of those to 5/2, and then I multiply across. So 5 times 5 is 25 on top, 2 times 2 is 4 on the bottom, and then I convert back to a mixed number. 4 goes into 25 6 times with a remainder of 1, so I get 6 1/4. You could also use the distributive property, but you can see that this takes a little more work. So 2.5, remember our and is telling us plus, so 2.5 means 2 plus 1/2. So I have 2 plus 1/2 times 2 plus 1/2, and now I'm going to do the distributive property. So I'm going to multiply 2 times 2 plus 1/2, and then 1/2, times the whole thing, 2 plus 1/2. That's what I'm doing on the second line. And then I'm going to distribute again. So 2 times 2 is 4, 2 times 1/2 is 1, 1/2 times 2 is 1, and then 1/2 times 1/2 is 1/4. And now I add all of those together. The whole numbers add up to 6, and then I'm left with a fourth. So I get 6 1/4. All right, I'm going to pause the video here and let you try a problem, and then we'll come back and talk about division.